What's going on, man? What's happening? So today we're gonna start talking about current dependent sources. In this case, we're talking about a current dependent voltage source. As you can see, right here we have our current dependent voltage source. As you can see, it is dependent on current IO with the gain of 5. So we got to multiply current IO by a gain of 5, right? And as we can see, current IO is here, and as we can see, current IO is traveling from the from low potential to high potential. So it's going to be that's where the current is traveling, right? And if we remember our current rules, right, the current in this whole entire circuit, or this whole entire wire, my bad, I didn't mean to say circuit. The current in this whole entire wire right here is IO, right? Because we know in circuit rules, wherever the current is in one place is at another, right? So the current is the same all throughout this wire right here, because this whole wire, this entire wire right here is a series circuit, right? So now that we covered that, now let's go and see how it will look like in an actual drawing. As you can see, this is what it looks like in an actual electrical drawing. You're gonna have your dependent current source right here, right? And then you're gonna have your current traveling in conventional current, right? Hold on. So you're gonna have your current traveling in conventional current, right? And as you can see here, we have it flowing an electron flow, right? We got it from negative to positive. But we also could have it flowing in a conventional flow through negative to to positive to negative, right? It doesn't really matter because the current here is going to be the same regardless of what we do. But just know that in electrical drawings, like 9 times out of 10, the current is going to be drawn in conventional flow. So you'll have to make it electron flow, you'll have to flip the current around like that. So, all right, we covered that. Now I believe we can just start solving, right? Well, actually, first, we have to label, right? We have to label um, our known voltages, right? So let's do that. So we're gonna have 0 volts at ground, of course. 0 volts on the ground, right? And then if we look at this battery right here, right? Well, actually we do know it, right? What is IO times 5, right? What is that times 5? That is gonna equal what? That is gonna equal, as we can see, let's see right here, it's gonna be, well, first let's label VA before we do anything. So we're gonna label VA. VA. All right. So the voltage on that battery is going to be VA. VA. Actually, what is the high potential? Yeah, VA is the high potential. Yeah, so VA. So first we're going to multiply it by 5, right? Because it has a gain of 5. The dependent uh, source has a gain of 5. So we're going to have VA minus uh, the ground, right? Because remember, this is a whole entire series circuit, right? So we're going to have VA minus the ground to get the voltage difference across it. And we're going to divide that by the total resistance of this wire, which is going to be 90, right? And that is going to be the current, right? This is going to be the current of let me put another parenthesis there. Make it neat. All right. This is going to be the current on this battery, right? So we know the current on the battery anyway. Or well, we know the voltage on the battery is this, right? So hold on, let me think about this. So yeah, the voltage difference across this battery is 5 VA minus 0 divided by 90, right? That's the voltage difference across this battery. So if we know this point, the positive point, right, is 0 volts, right? Because it's connected to ground. So the positive is 0 volts. So in order for the positive to be 0 volts and we have this voltage difference across this battery, that means this point right here, this node right here, this has to be negative of this, right? It has to be negative of that. So let's write that real quick. We can write that down. We can even go ahead and simplify it. So we're going to do 5 VA, or we can do VA negative VA 5 over 9, right? Or 5 over 90. And what's 5 over 90 simplified? How many times can 5 go into 90? 90 divided by 5. That's going to be 18. So that's going to be 1 over 18. So VA should equal, well, not VA, my bad. This point right here should equal negative VA 1 over 18, right? So whatever VA is, make that negative and multiply it by 1 over 18. And that should give us the voltage here. We'll see if that's true in a little while, but as for now, we're not going to really worry about that. So let's get busy. All right, so let's start writing our equations. All right, let's solve for that first circuit. We're going to have VA, the high potential of VA, minus the difference. Well, yeah, the voltage difference of the battery, divided by 80, right? Divided by 80. And that's our first equation. So we're going to add that. And then we're going to do VA, right? We're going to find the voltage difference across that wire, which is going to be VA minus ground. And we're going to divide that by the total resistance of 90, right? So we also have that. Right? And then we're going to do our last thing. Well, before we do that, we need to figure out what is the... So let's see if this is going to be a voltage lift or a voltage decrease, right? So we're going to go to ground. We're going to travel through the battery, right? And as you can see, we're going positive to negative, right? So this is a voltage decrease, right? This is a voltage decrease of, hold on, let me think about how I want to word this. All right, so as I was saying, this is going to give us, as we go through here from the ground from positive to negative, that's going to be a voltage drop of the voltage difference of the battery, right? There's going to be a voltage drop, the voltage difference of the battery. So let's go ahead, let's write that. So we're going to have VA minus, right? Or my bad, it's going to be VA. Hold on, actually, how do I want to write this? So we're going to have VA minus negative VA 1 over 18. And all of that is going to be divided by the total resistance of 100, right? All right. So now that we have figured out, and that's going to be equal to, all of that is going to be equal to 0. All right, now that we've written our equation down, now, all right, let's start simplifying. Okay, so we got to figure out what goes into what. We got to figure out what goes into 80, 90, 18, and 100. So let's write that out real quick. So we're going to do 80, 90, 18, and 100. I guess I could enter that in the calculator, but that's going to take a while. Oh, fuck it. Let's just do it. So we're going to have 1 over 80 plus, what is it? Let me put these in fractions just in case. I guess calculator messes up or something. 1 over 80 plus 1, wait, crap. Plus 1 over 90 plus, what are we doing? Plus 1 over 100 minus, or is that going to be, no, that's added. Okay, yeah, we're adding that. We're going to do plus 1 over, oh crap, plus 1 over 18, right? That's going to give us 107 over 12. So let's see what we can do with that information. So we're going to have 1 over 7 divided by 1200. And hold on, I just want to make sure that answer is correct. All right, I see what I did wrong. I forgot to multiply the 18 and the 100. That's what I did wrong. So let's do that. So we're going to do 1 over 18 times 100. That's going to be 18. That's going to be 1800. And this should give us the right answer. All right. So we're going to have 21 over. So let's see if that's true. So we're going to have 5 by 40 times 3 over 2. Is that the right answer? I think that is. So we're going to have 3 over 2 there. Because 100, negative 100 times 80, that's going to be 3 over 2. I mean, negative 3 over 2. We bring it to the other side of the equation, it's going to be negative 3 over 2. So, all right, let's see if that's the right answer. So we think 0. We think VA is going to be equal to what? 43 positive 43.9, right? That's what we think is going to be equal to. So let's see if that's correct. So let's run our simulation. All right, and that is indeed correct. Pull it up. Yep. Pull up the calculator too. Yep. There you go.